Hi guys, and welcome to section 3 of our statistics chapter, Misleading Graphs and Statistics. So this is actually one of my favorite lessons to teach because lies. Really, it's not lies, but there are ways you can manipulate your data and how you display it to change what it looks like, because people don't usually look too closely. Okay, so for misleading graphs, some things you need to look out for. You need to look at the scale on the side, and sometimes even on the bottom, but usually it's on the side, to make sure it's being counted evenly or across the bottom. Make sure it's counted evenly, and you really want it to start at 0 to be the least misleading. Okay, so what that looks like, I'll just show you some examples out of the book of what that looks like. Okay, so two ways you can look at these two graphs right here. Okay, and it asks, the graphs show the same data, however, they look different, right? So you can, again, by just changing the scale on the side, do you see how it's different? This one counts up by 4s, this one counts up by 2s. Then you could even have one that counts up by 1s, okay? And so by having a tighter, bigger jumps in your scale, it makes the differences in your data seem not as big. When you have smaller jumps on your scale, makes the differences look lots bigger. So depending on what you want people to think, changes which graph you would use. So if you want a sharper increase in price, if you want to make it look like there's bigger differences, you'd totally use graph B, right? And then if you wanted to make it look like the prices haven't changed very much, then you'd use graph A. So do you see how, we're not necessarily lying. I like to say lies for this assignment just because it's fun and silly. But really, again, statistics is the language arts of math. And so you can manipulate the data. You can change your scale to make it look however you want, which I think is, it's just, it is what it is how that works out. Okay, so look at this. The line graphs show monthly profits of a company from October to March. Okay, it's the same spread. Which graph suggests that the business is extremely profitable? Which one makes it look like, oops, sorry, welcome to school.
Gavin Robbins, meet at the car. Gavin Robbins, meet at the car.
There you go. Alrighty, so looking at the two graphs, graph A looks way more impressive, right? If you were a company. But let's take a look at what's happening on graph A. It goes from 14,000, 14,500, 15,000, and then 100, 200, 300, 400. So what happened is we just zoomed in on this section and we stretched it out. Cheating, lies. Whereas if you keep a consistent scale over here, not as many lies. Okay, that's much more consistent than this one. This one, not so valid. This one would be valid. Okay, lies. Oh, statistics, good times. Okay, so the next way, that's kind of what's happening with misleading graphs, okay? So you want to look at the scale, you want to look at, and you want it to start at 0. I'll show you another example of why you want it to start at 0 in just a minute. Okay, the other thing for misleading statistics, Okay, and what we're talking about here, we're just really talking about our 3 M's, the mean, median, and mode. So before we even talk about how we can be misleading with these, we call all of these measures of central tendency. Probably in the book they call them measures of center. Central tendency is the fancy actual statistic term for it, okay? So let's review before we talk about how we can be misleading with these statistics. Let's remember how to do these statistics. So the mean, this is what we normally think of when we think of the average. Okay, you add up all the numbers, and then you divide by the number of numbers. Okay, and I'll show you an example in a minute if that doesn't make sense to you. But you add everybody up, then you count how many numbers you added together, and that's what you divide by. Okay, the median is the middle number after they've been put in order. If you just find the middle number of a hodgepodge random group of numbers, that tells you nothing. So you have to put the numbers in order first, then you find the middle number. And that's literally, I like put my fingers on the end too, and then just bring them in together till you find the middle. If you have 2 numbers in the middle, then you find the mean, you add them together and divide by 2 to find the middle of those 2 numbers. Okay, and then the mode is the most, that's how I remember mode, most frequently occurring number. Okay? All right, so that's our mean, median, and mode. Now, here's what happens. Do you remember a term called an outlier? An outlier is a number that doesn't match, or several numbers that doesn't match or come close to the other numbers, okay? If you have an outlier, what happens is it really affects the mean, okay? It'll pull the mean in the direction of the outlier, which means the mean all of a sudden does not describe the middle of the data as well as it used to. So the best description for a set of data that has an outlier would be the median. Let's be honest, the mode really doesn't tell us a whole lot of anything. Okay, so really we're flipping between the mean and the median. If we have symmetrical data, then the mean is the best one. If we have an outlier or non-symmetrical data, the median is the best one to use. Now, you can use, depending, like if you were an advertising company and you wanted to change what the data looked like, then you can absolutely use your outliers to change the mean and say, you know, this is the average, this is the middle of the data, and technically they're not lying, but lies. It's not the most valid description. So let me show you what this looks like in an example. So an amusement park boasts that the average height of their roller coaster is 170 feet. Average, again, could actually be used to describe all 3 of those. They're all 3 measures of central tendency. Okay, so it says the average is 170 feet. Let's look at this data though. That's under 170, that's under 170, over and under. Do you see how this one's kind of an outlier? So that outlier is pulling the data higher. Okay, so again, remember this is how to find the mean. You add them all up, and then there's 1, 2, 3, 4, 5 numbers we added together, so that's what we divide by. That's how we find that. Okay, so do you see how the mean gets pulled way out from the rest of the data because of this outlier? Okay. So again, they're not technically lying by saying the average is 170, because technically it is. but it's not really the best measure of central tendency. The median, which is the middle number after we put them in order, it describes more of the roller coasters. Okay, so that's what it says here. The average is the mean because there's an outlier, so it's kind of misleading, lies, to use this measure. It's making them look better than they really are. Okay, so we can practice this one more time together. I'm going to get my calculator. Okay, it says find the mean, median, and mode of the sofa prices here. And then which measure might be misleading in describing the average cost of the sofa. So looking at this, can you see how we have an outlier? And so that's going to pull our mean, in this case, down. But let's do it for realsies. Okay, so we're going to add all of these numbers up. 1,700 plus 1,400 plus 350 plus 1,600 plus 1,400. Okay, and then we're going to divide by 1, 2, 3, 4, 5. Divided by 5, and the mean is 1,290. The median, so we got to write them all in order. So the lowest is 350, and then we got two 1,400s, 1,400, and then 1,600 and 1,700. Okay, so then the middle of the data is 1,400, and then the mode, most frequently occurring, is also 1,400 because we've got two of those. Okay, so center of the data, not quite the center of the data. So this is the one that we would use that could be misleading. Technically, it's middle of the data, but if you use that, it makes it look like your prices are lower than they really are for the most part. Lies, misleading data. Okay, so that's how you can lie with your data. Let's be valid. Okay, and then I'm going to show you one other. This example just makes me laugh every time I do it every year. Okay, the graph suggests that Cy Young, baseball, I think, had 3 times as many wins as Jim Galvin. You see that, his line? You have this line, and then you come up here, and you can almost put 3 of his lines on this line, okay? Did you see that? So it makes it look like Cy is like way higher than Jim, okay? Is this a valid conclusion? Well, is it? What happens right here? These all go up by 50 just fine, but it goes from 0 to 350. If we put the ends of these lines, imagine with me, these lines pull back to go evenly. That would be 300, 250, 200, 150, 150. It'd be off the TV. Okay, those lines would be off the TV. All of the sudden, is Jim a third of Cy? Huh? No, he's not that much less at all. And if you look at the numbers, I'm guessing that's like, what, a 360 there to like a 510 at most. Okay, so he's not even twice as much. But because we have this jump right here, we don't have a consistent scale. And funny thing about that situation, a couple of years ago, we were in our teacher meetings, and Mr. Johnson, who was the 9th grade math teacher at the time, he leaned over to me and he said, should we tell them that they have a misleading graph? Because they did this very same thing. It's the same thing that happened kind of over here as well. When you zoom in on just the top bit of your data, it makes it look like there's way bigger differences. And that's exactly what they had done in our teacher meetings, is it went from like 200 to 220, and it made it look like there were huge differences when really, if you zoomed out and saw the whole thing, it wasn't that big of a difference, okay? So misleading graphs, remember misleading graph, you want to look at your graphs and make sure your scales are consistent, make sure it's starting at 0 and counting evenly. And then with your statistics, Mostly watch for your outliers, because if you have an outlier, that's going to pull the mean, and then that is the one that's going to be not valid anymore. Okay? Alrighty, bye.